Hey guys, this is the notes for lesson 4.3. We're going to talk about different discrete probability distributions, specifically one called the geometric distribution, and then one named after a French guy named the Poisson Distribution. Most of you will call it the Poisson Distribution, but whatever. So the geometric distribution is a discrete probability distribution, so it's still individual x values, but now there are different conditions from what the binomial had to have. You will have to, this time, repeat your trial until a success occurs, meaning you're going to keep trying and trying and trying and trying. There will only ever be one success. So unlike binomial, where you'd be finding the probability of 2 successes or more than 7, there's only one success. You're just finding when it occurs. Your repeated trials are still going to be independent. That's going to be true for all of these. The probability of success will still be p, and it will still be constant, part of the independence. The formula for this is related to what we could have already done anyway. You will have, like I said, one success, so we have p times, and then q, which is the complement of p, is going to be to the x minus 1 power. Meaning if you have one success and you want to be successful on your 7th trial, you need to have 6 failures, 6 of those q's multiplied together. So it's a pretty straightforward formula, but it's going to be distinguishing when it's this scenario versus a binomial that will be important. So an example of this is that 21% of Americans say Thanksgiving is their favorite holiday. You're going to select at random 20 Americans and keep asking the question about their favorite holiday. We are going to find the probability that the first person who says Thanksgiving is their favorite is the 6th person you select. So even though there technically is a fixed number of trials, we are calculating when the success occurs. And if that's the case, this is going to be one of the geometric distributions. In this case, the probability of success would be 0.21, 21%. Say Thanksgiving. So you could put 21 out of 100, or you could say 0.21. But if that's your probability of finding somebody who says Thanksgiving, the complement of that is the probability that they don't say Thanksgiving, so 79%. We are going to use an x value of 6 because we want the 6th person to be our success. So in the formula, that ends up looking like 0.21 times 0.79 to the, that's a typo, to the 5th power. And I don't know if my answer is right because I probably used that. So 0.21 times 0.79 to the 5th power, because I should have done x minus 1 and I just used x. We want 5 failures and 6 successes. So that should be 0.0646 approximately if you round to the nearest 10,000th. Yeah, not that answer. The next one we're going to look at is the Poisson distribution. It's going to have certain conditions that we still have to look for. Specifically, this one's going to have counting the number of times an event occurs, just like the binomial, but now there's some given interval, some given set period. It could be a time period, an area of space, or a volume of space, but there's going to be some type of interval that's stated to you. The probability of the event occurring is the same for each interval, so maybe for each acre of grass, you have the probability of finding 4-leaf clovers or something. It will be the same probability for each acre. The number of occurrences in the interval is independent of the number of occurrences in other intervals. When this works, you're going to have this formula that is not intuitive. I couldn't even tell you where it comes from. And you need to write down that it's mu to the x times e to the negative mu all over x factorial. Mu is going to be that average number of occurrences per interval unit that's stated to you. So make sure you get that one down. So for this example, the mean number of referrals given every day is about 5. That's a made-up number. I don't know what it actually is. We're going to find the probability that on any given day, 4 referrals will be given. So we're going to use this setup where we are going to find a total number, but there's some interval, and that interval for this one is a day. It's a time period. So if the average in that time period is 5, I'm using mu as 5. And x would be 4. We want to find the probability of exactly 4 referrals. So we're going to use that formula. I'm going to substitute in 5 to the 4th, because that's mu to the x, times e to the negative mu. Now, e is not a variable. It's a constant value. It's on your calculator. I'll show you in a second. But we're going to raise that to the negative mu power, so the negative 5th power, and divide that by 4 factorial. So on your calculator, I know Inspire's yours will be slightly different. Call me over if you can't find it. But I want 5 to the 4th. And then your e value is, mine's in blue, yours might be a different color, but it's above the ln. You'll need to push second and ln for natural log to the -5th. And then we will divide, oh no, don't push that button. Then we will divide all of that, which you could do it as a fraction feature. It won't make a difference for order of multiplication division, but divide by 4, exclamation point, 4 factorial, which means you need to scroll over to probability and get your factorial. Unless I did it wrong. Awesome. Oh, because I used the wrong negative button. Sorry. So it was typed incorrect. So 0.1755 approximately. The next problems have a mix of binomial, geometric, and Poisson distribution. Literally pause this video, take a moment, and see if you can figure out which one's supposed to be which. Seriously, push pause, read through them, try and figure it out yourself. So hopefully if you did actually pause it, you've read through that part A gives you the average per year, and as soon as you see an average per time period, that's the Poisson distribution. Whereas part B, you have a set number of adults, you know the probability per adult, and you are finding the probability of a set number of them. So it's not when you get somebody who says yes, it's how many yeses. That's a binomial setup. Whereas part C, you have that probability, but you're going to keep buying oatmeal boxes until you are successful. That's a geometric setup. The last one, where it gives you a probability, it gives you the number of seniors that you're asking, and you're finding a probability of how many agree. That's binomial, which is cut off on the screen, but it's binomial. There we go. Binomial. So now we have them classified, we can actually go calculate those. Since we said part A was a Poisson distribution, we're going to use the formula. And since the mean per year was 0.6, mu is going to be 0.6. We are wanting to find exactly one major hurricane, so x would be 1. We're going to just substitute those into our formula. So 0.6 to the first power times e to the -0.6 power, all over 1 factorial. Quick side note, 1 factorial is equivalent to 1. You don't really need to type in divide by 1. But even if you did, sorry about the bell, you would get 0.3293 approximately. Bit of review for part B, we said this one was binomial. Since we're just finding the probability of just 4, so not more than 4 or at most 4, anything like that, just 4, we can use your calculator's binomial PDF function. We would want to tell it we are having 12 trials, we have a 55% chance of success, and we want 4 successes to occur. As long as I type that into my calculator correctly, I got about 0.0762. For part C, we said, or I said, that this one was a geometric distribution. So we need to think of our formula and figure out P, Q, and X. P is the probability of success, and it says the probability of winning is 1 out of 8. So that means the probability that we don't win is 7 out of 8, the complement. We want to win on our 6th purchase, so X would be 6. So when I put that in my calculator, apparently every time I did geometric on this PowerPoint, I did it wrong. I would want 1/8 times 7/8, but do not put that to the 6th power. I copy-pasted and didn't read correctly. It should have been 6 minus first power. This should be a 5. It should be to the 5th power. You should get about 0.0641 approximately. So not that answer. The last one, I didn't animate it apparently, but this one was a binomial. Since there was the 14%, that will be our probability of success. We are going to be asking 7 people. That will be our trials. But this one we want 2 or 3. There's 2 ways you could do this. Neither is any easier than the other. You could just think, well, or is a sum of values. So I could find just the probability of a 2, just the probability of a 3, and add them up, getting this answer. Or you could think of it as, I'm going to do a CDF. I'm going to make my calculator add them for me. But if you use the cumulative with 3, this will calculate 3, 2, 1, 0. I don't want 1, 0. We just want 3, 2. So I'm going to take away, I'm going to subtract off the 1, 0. So I used a CDF of 1. You get the same answer regardless of which method you use. It's really just which one you understand better, which one you happen to think of at the time. So what we're doing for your assignment is a mix of identifying which type it is and knowing how to calculate it once you know which type it is. So good luck.